Today's topic is about the second type of bonding, which is known as the covalent bonding. So basically what happened, the electrostatic attraction by the sharing of electron, this result in a formation of a bond, and we call that as covalent bond. Like example, what happened, hydrogen, if this is a nucleus of the hydrogen, it contains one electron in the outermost shell. Then there's another nucleus and one electron in the outermost shell. So hydrogen is a non-metal, it cannot lose electron here easily. So what these two hydrogen atoms will do, they will share the electron between them. So the shared pair of electrons between the two hydrogen atoms, the nucleus is attracting, the nucleus of first hydrogen is attracting those pair, and the second is also attracting the pair. So this result in a formation of a covalent bond. So bond which is formed by a sharing of electrons. The covalent bond is also a strong bond, and it is by electrostatic attraction between the bond pairs and the nuclei. Like the nucleus is attracting the bond pair or the shared pair. This attraction is known as a covalent bond. And as the structure is getting bigger, like example, strength of the covalent bond, we can demonstrate by high melting point of a giant atomic structures like diamond and graphite. You will find that diamond and graphite both have the giant structures. So as they have a giant structure, and throughout the structure, they have a covalent bond. And how we can identify or say the strength of a covalent bond is stronger? Because when we find the melting point for diamond or graphite, we'll find it is very high. So high melting point is an evidence that they need more energy or the bond is stronger. Now, if we pass X-ray diffraction or passing an X-ray, this is an electron density map. What is the electron density map? Electron density map shows the region of finding electron is maximum. That's called electron density map. So you can see the X-ray diffraction of a hydrogen molecule shows a high concentration of a charge between the nuclei. So greater concentration of charge is there between the nuclei, and strong attraction is there. Exceed the repulsion, because there's also a repulsion in this case. What is a repulsion? As you have a nucleus which is having one proton, that's one hydrogen. Then there is another nuclei. So between the nucleus there is a repulsion. Between nucleus and electron there is attraction, and this attraction keeps this electron pair within the region. That's why higher electron density within the two molecules. So these lines are representing the electron density. This is not the shell or the orbit. Means probability of finding electron is maximum between the two nuclei. As we move away from the as we move away from the center, the probability or the electron density decreases. How you identify electron density is decreasing? The distance between the lines shows the electron density. If lines are closer, it means high electron density. If lines are far apart from each other, it means low electron density. Is it clear, the concept of a covalent bond? The bond which is formed by sharing of electron, and we can use X-ray diffraction to work out the electron density. And we find the similar pattern for other elements as well, that the region of or electron density is higher at the center or near between the two nuclei, and as we move away from the center, the electron density decreases. Any doubt in this? Now, when we represent, we can use a dot and cross diagram. We can use a dot and cross diagram to show the bonding for group 4. So when element belongs to group 4, it is having 4 electron in the outermost shell. So how many it will share? It will try to complete octet, so it will share 4, and unshared will be 0. If it is group 5, to complete octet, it will share 3, and out of 5 it share 3, so unshared will be 2. If it is group 6, it will share 2 and unshared will be 4. And if it is group 7, it will share 1 and unshared will be 6. Group 8 does not form a bond. Only in case of hydrogen, it is having 1 electron and it will share that 1 electron only. Hydrogen does not, it will not complete octet. Others will complete octet. So like if we want to draw the structure of ammonia, which is NH3, so nitrogen belongs to group 5, so it will share 3 electrons. So you can see the 3 electrons the nitrogen share, we represent by a cross, and hydrogen belongs to, is having 1 electron, so it will share that 1 only. So this is a electron of hydrogen. No unshared electron for hydrogen because it's having only 1 electron. But nitrogen belongs to group 5, so it shared 3. So unshared should be 2. So you can see the 2 unshared. So they have a single covalent bond. When you check oxygen O2, oxygen belongs to group 6. So it is belongs to group 6. How many it will share? It will share 2 electron, and how many unshared will be there? Unshared will be 4. So 2 oxygen atoms. Between them, the shared electron you can see, and unshared will be 4. And this is a double covalent bond. The covalent bond can be double, it can be triple, or it can be single. Where BCl3, boron tetrachloride. In case of boron, it is exception. Like you can see boron belongs to group 3. So if it belongs to group 3, how many electrons will be there in the outer shell? It will have 3 electrons. So if it is having 3 electrons, it should act like a metal, it should lose electron. But we don't observe boron is losing electron. Why it's not losing electron? So reason for that, because when you write the atomic number for boron, it's 5 and atomic mass is 11. So when we find the number of the proton, that's equal to 5, number of electron also equal to 5, and number of neutron 5 minus 11 minus 5, that's equal to 6. So when we draw the structure, the nucleus contains 5 proton, there are 6 neutrons. First shell it will have 2 electron, and the second shell it will have 3 electron. But because it is smaller in size, so it's not able to lose its electron easily. That's why instead of losing the electron, it is sharing the electron. But when the boron is sharing electron, it is not able to complete octet because it's not having enough electron to complete the octet. So some exceptions are there in which the element will not complete its octet. But other element, because it is reacting with or forming a bond with chlorine, so chlorine share 1 electron. So overall 3 electrons are shared. So you can see this BCl3. So boron, the chlorine atoms are stable. That's why overall the molecule will be stable. But there's also another type of a bond you will study that's known as a dative bond, which can make this molecule more stable. Is it clear? This part? For a boron, because it's not in a group 4, 5, 6, or 7, that's why it is not able to complete its octet. Now the second type of a bond, what we call that as a dative bonding. Covalent bond, you can see the electrons which are shared between the two atoms. one electron given by like hydrogen here, another one by nitrogen. Same case, one oxygen is giving electron and the other one. Same way boron and chlorine are sharing. But what is the dative bond? A dative bond means there is a sharing of electron, but both electrons are coming from one atom. So both electrons are coming from one atom, then we call that as a dative covalent bond or dative bond. You can say dative bond or dative covalent bond. That's the main difference. Both are covalent bond, but the difference is that a simple covalent bond, electrons, each the elements which are present to form a compound, both are sharing the electron, like both are bringing their own electron. But in case of dative, both of the electrons are from one atom. So example, we have say ammonia. In case of ammonia, nitrogen forming a single bond with hydrogen, and there's a lone pair. Lone pair means unshared electron is there, but all are stable. You can see nitrogen is having 8 electron, hydrogen having 1 electron. But what happened, like example, if we add an acid to this ammonia, means we add a proton. So proton means it is electron deficient. It does not have any electron, because hydrogen, when we write the structure of our hydrogen, it is having 1 proton and 1 electron. This is the structure of hydrogen. But when we say H plus ion, so H plus ion means it's only proton, there is no electron, because electron is being lost. So this proton experience the attraction from this lone pair. This is electron pair or lone pair. So due to this, this hydrogen, which is not having any electron, is attracted towards this lone pair, and it will adjust within the structure and this is the ammonium ion. So you can see here, this hydrogen is stable, hydrogen stable, hydrogen, nitrogen already stable, and this hydrogen is also stable because it is having 2 electron, even though there is a charge, but 2 electron, so that make it stable. So this bond, one of the bond is unique. All are covalent bonds, but one of the bond is unique. How it is unique? Because both of the electrons which are involved in the bonding are from one atom. That's why we call that as a dative covalent bond. The other bonds, the electron which are shared between nitrogen and hydrogen. So one electron is from hydrogen, one is from nitrogen. So these bonds are known as simple covalent bonds. So nitrogen forming, so how we represent in terms of line. So we show an arrow when there's a dative bond, we show an arrow from an element which gives the both electron pair, means which give both electrons in a pair to an element which take those. So this is how we represent a structure of ammonium ion. Is it clear? This example. This is a dative covalent bond. Then there is also like another example. So another example for this bonding, like hydroxonium ion, which is H3O. So what is water? When we draw the structure of the water, in case of water, oxygen forming a single bond with each hydrogen, and there are two lone pairs. Now what happened if we add an acid? Acid means proton we are adding. So this proton, this is not having electrons. So if it is not having electrons, so it wants to gain a stability. So it is attracted towards the lone pair, one of the lone pair of oxygen. So when it is attracted, what will be the new structure? It will be H. And the lone pair, one of the lone pair hydrogen is proton, form a bond. So you can see all are stable now. All the hydrogen which are attached to this oxygen are stable. Oxygen is already stable because 2, 4, 6, and 8 electrons. And this bond is known as, two of the bonds are simple covalent, but one of the bond is dative covalent, which will give hydroxonium. Another example. So another example of this dative bonding, it can occur between the molecules as well. How it can occur between the molecules, as I explained the structure of boron trichloride. Boron belongs to group 3, so it is sharing 3 because it is having 3 electrons. So it is sharing 3 electrons. And chlorine are all chlorine are stable, but boron you can see when it is sharing 3 electron, it is having 6 electron. So it need 2 more electron to be complete octet. So how it complete its octet? Like example, if nearby another molecule is there of boron trichloride, so you can see there is a lone pair. So all are stable in this. So this lone pair is attracted, or boron is attracted towards the lone pair. So what happened? We'll have a different structure like boron. Three simple covalent bonds are there. This is one molecule of boron trichloride. Then there's another molecule of boron trichloride. I will use a dot and cross diagram. That's why I erased this. So this lone pair attracted towards boron, or chlorine lone pair form a bond with this boron. So what you will find that now it is completed 8 electrons. So when it completed 8 electron, it means the boron is also stable. And this happened for other molecules as well. Like it's like a chain. Which make them stable. Is it clear? The formation of a dative bonding in boron trichloride. The previous was hydroxonium, and the first one was ammonium ion. So you can see a dative covalent bond formed when the shared pair of electron is only from one of the bonding atom. And the dative covalent bond is also called a coordinate bond, or simply you can say dative bond as well. So hydroxonium ion, you can see H3O with a positive. So oxygen and hydrogen are stable, but there is a proton. So that proton attracted towards one of the lone pair of oxygen, which will result in a formation of H3O. NH4, nitrogen and hydrogen all are stable, but there's a lone pair that will attract hydrogen, so one of the bond is dative. And you can see if you have two molecules like boron trichloride is there and ammonia. Ammonia is stable, but boron trichloride boron is not stable. So lone pair of a nitrogen is attracted towards boron and it will form a dative bond which will make it stable. Is it clear? The dative bond or coordinate covalent bond. So in a dative bond, the electron pair is only from one of the element involved in the bonding. Any doubt in this? Then using the bond pair and electron pair, you can predict the geometry of the molecule. So you have to learn this table. On the next slide, you can see this table. So using this table, you should be able to predict the shape or the geometry of the molecule. For example, if a molecule is having two bond pair and there is no lone pair. So if there are two bond pair and there is no lone pair, then what will be the geometry, the structure? It will be linear, and the bond angles also. This is the bond angle. So what will the bond angle? The bond angle will be 180 degree. An example like carbon dioxide, carbon disulphide, hydrogen cyanide, and BF2. Look, when you're predicting a geometry, if there, when we predict the geometry or the shape, if the double bond is there or triple bonds are there, they are always considered as a single bond when predicting the geometry. So example, if I draw the structure of carbon dioxide, so carbon forming a double bond with oxygen, now if I show this on oxygen there are lone pair, but carbon there is no lone pair, belongs to group 4. So when I show the geometry, it will be O double bonded with C and then O. Now what you see, if the question is predict the geometry, so when you try to predict the geometry, if the double bonds are there or triple bonds are there, you will consider that as a one bond. One bond means two electrons or one pair. So how many pairs I will consider? How many pairs are there? This is one pair and this is a second pair. So how many pairs of electrons are there when I'm predicting the geometry? So number of the bond pair are 2. And there is no lone pair. There are lone pair on oxygen, but when we are predicting a geometry, we take the central atom. We check the central atom in this example. The central atom is carbon. So carbon does not have. So how many bond pairs are there? 2. How many lone pairs are there? 0. So if the two bond pair and lone pair, then what will be the structure? It will be a linear structure. In a straight line structure with a bond angle of 180 degrees. Is it clear? The linear structure. So when you're predicting the geometry, you consider double bond and triple bond as one pair, because they're in the same direction. So when we are predicting the geometry, in prediction of the geometry, they are considered as one. In practical, yes, there are 4 bond pairs, but in predicting the geometry, if there is 2 bond pair in a same line, like if there's a double bond or a triple bond, that is always considered as single bond. Another example like hydrogen cyanide, HCN. For hydrogen cyanide HCN, if I draw the structure, carbon belongs to group 4, so it will share 4 electrons overall. 3 it shared with nitrogen and 1 it shared with hydrogen. Now, the question is predict the geometry, like what will the shape of this molecule? So what is the central atom? The central atom is carbon. So you always take a central atom when you're predicting a geometry. The central atom is carbon. How many bond pair I will consider? Because it is like H, C, triple bond, N. Now the central atom, one side is a triple bond, another side is a single. So triple bond I'll consider as one bond pair. And this single bond is already one bond. So how many bond pairs are there? How many pairs involved in the bonding? So 2 bond pair. How many lone pair? Lone pair means a free electron on the central one. There are free electron on nitrogen, but we are predicting a geometry always with a central atom. So carbon is a central atom. So there is no lone pair. So if there is no lone pair and there are all bond pair, so what will be the structure or the geometry? It will be linear structure with a bond angle of 180. Means the bond between H, C and N, the bond of H, C and N, that will have an angle of, this is not less than, that means the sign for angle, that will have angle of 180 degree centigrade. So 180 degrees. Centigrade is for temperature by mistake. So 80 degrees is. So whenever you're predicting a geometry, like another example, if I give, say, carbon disulphide. So carbon disulphide, carbon belongs to group 4, so it will share 4 electrons. Sulfur belongs to group 6, so it will share 2 electrons. And 4 will be unshared. When I predict the geometry, carbon is a central. So according to central atom, like carbon disulphide, so central atom contain, this is one bond pair, this is another. So there are 2 bond pair. In practical, there are 4, but when predicting a geometry, double bond and triple bond are considered as one bond pair. They're in the same line. So I have 2 bond pairs. About the lone pair, 0. Then what will the geometry, the linear structure with the bond angle of 180 degrees. Is it clear? This predicting the geometry for the molecule or shape of the molecule. Any doubt in this part? The first one, the linear structure. Then second one, the structure, you have to learn this table. The second one, if there are 3 bond pairs and there is no lone pair, then it will be trigonal planar with a bond angle of 120. And these are some examples like BF3, AlCl3, SO3, nitratine, carbonatine. So they all have the bond angle of 120. So first thing is drawing the structure, like you should be able to draw the structure, and second thing is predicting the geometry. Because without a correct structure, you cannot predict the geometry. So if I say what is the structure of sulfur trioxide, SO3. So SO3 means sulfur bonded with 3 oxygen. Now sulfur bonded with 3 oxygen, how we can represent? Because sulfur belongs to group 6, so maximum it can share 2. So how there are 3 oxygen attached to this? So first what happened? Sulfur belongs to group 6, so it formed one bond with oxygen. So sulfur is stable, having 8. All the oxygen are also stable. One oxygen is stable, but another oxygen will come, oxygen molecule, but then it will form a dative bond. What is the meaning of dative bond? That both of the electrons are from sulfur. So there is a dative bond here. Then another oxygen forms a dative bond. And this was a covalent bond. So when I draw the structure, S double bonded with O, and there is dative bond with one oxygen and dative bond with another. So how many bond pairs are there? So this double bond is considered as 1, then this is 2, 3. So there are 3 bond pair. How many lone pair? Lone pair means free electrons. So you don't find any electron free on the sulfur, so lone pair is 0. If 3 bond pair and no lone pair, then it will be trigonal planar. So means the structure of sulfur and with a bond angle of 120. So this structure, all the bond angles are 120 degrees. Is it clear? This structure of sulfur trioxide, which is trigonal planar. So you should be able to predict the geometry as well as the bond angles. This will be trigonal planar. Same way, if I draw BF3 or BeCl3. So when we draw BeCl3, BCl3, not BeCl3, boron trichloride. So chlorine forming single bond. So all of them are stable. The boron is having 6 electrons, but for example, if there is no other like dative bond, so when we check the central atom, so on our central atom, how many bond pairs are there? 3. How many lone pairs are there? 0. So what will be the geometry? It will be trigonal planar with a bond angle. What will the bond angle? The bond angle will be 120 degrees. So you should learn the bond angles as well. For each geometry, a specific bond angle is there. Is it clear, the structure, trigonal planar? Any doubt in trigonal planar geometries? Like same thing, nitrate ion is there. Nitrate ion, NO3, with a charge -1. So if nitrate ion is there, nitrogen belongs to group 5, but charge -1 means it took 1 extra electron. So now how many electrons will be there? It will have 6 electrons. That's why the charge is -1. Then how it will be stable? It will form a double bond with one of the oxygen. Then it will form dative bond with other 2 oxygen. So you can see nitrogen double bond with one of the oxygen and dative bond with 2. This is one of the possible structure. And the overall charge NO3 is there, so it is having -1. And how we predict the geometry, you can see this is considered as one bond pair, second bond pair, third bond pair. So 3 bond pairs are there. If 3 bond pair, when predicting the geometry, we check the bond pairs. If 3 bond pair and there is no lone pair, then what will the geometry? The geometry will be trigonal planar with a bond angle of 120 degree. Any doubt in this part till now? Same way, if it is having a 4 bond pair, the third one is a tetrahedral. It will be tetrahedral if it is having 4 bond pair and no lone pair. And you can see this is a 3D structure, like representing one of them is in, another one is out. Like the structure is 3D structure. It's like 2 of them are in the same plane. You can see 2 of them are in the same plane. One is out of the plane, one is into the plane, like into the paper and out of the paper. With a bond angle, this bond angle will be 109.5 degrees. So example of this, like when we draw CH4, methane. So in case of methane, when you check carbon, form a single bond with 4 hydrogen atoms. So you can see the number of the bond pair. There are 4 bond pair, and about the lone pair 0. If 4 bond pair and no lone pair, then it will be tetrahedral. And tetrahedral, how you draw this structure? 2 of them you will show in the same plane. Any 2 you can show in the same plane. One will be out of the plane and another one is in, like a 3D structure. Like one is inside, one is outside, 2 of them in the same plane with a bond angle of 109.5 degrees. So you have to learn this angle as well. So whenever 4 bond pairs are there, the structure, the geometry is always tetrahedral. With a bond angle of 109.5 degrees.